Morning. Today we'll start with our next topic, flow control and error control in TCP. In the previous lecture, we have studied the connection establishment between TCP. And right now, before going to the lecture, so today's thought: when our signature change to autograph, this marks success. So Dr. APJ Abdul Kalam, the President of India, the former President of India, he has said a very nice thought. Okay, if you want a real success, when you achieve it, when your signature will become the autograph. Okay, so very clear thought. So before going to the error control and flow control, so first we'll understand what is the concept of windows. Okay, so in this TCP connection or in the TCP protocol, we are going to learn the windows technique and how exactly the data is transferred from sender to receiver without error. Okay, and if error is happen, then exactly what we can do. Okay, so first we understand what is windows. So before discussing the data transfer in TCP and the issues such as flow, error and congestion control, we describe the windows used in TCP, and the TCP uses two windows, send window and receive window, for each direction of the data transfer, which means four windows for a bidirectional communication to make the discussion simple. So we make an assumption that communication is only unidirectional and the bidirectional communication can be inferred using the two unidirectional communication with the piggybacking. So I hope you don't understand anything. When we come to the end of or we are just proceeding with the lectures, then you will understand exactly what is this. So in a transport layer, we are transmitting actually the packets. Okay, so what is meant by the packet? So when the from the application layer there is a transport layer, so whatever the data or whatever the we are sending the message from application layer, that is come to the transport layer, and the transport layer is exactly the data is transport to the receiver. So how exactly that data is transferred without error, that's what we are going to learn. So we are going to discuss here in this topic, so that is a send window and receive window. So first we will understand the send window and receive window. So send window in a TCP, so send window includes in the sender's PC, and receiver window is in a receiver side. So here I am showing you the send window. Now you can see here, suppose there is a first outstanding byte, okay, and here is a next byte to send. Okay, so here you can see 200, 201 up to 260. So these are nothing but what? These are nothing but the window size, or you can say that is nothing but the window of that particular byte. So there are 100 bytes, or we can say these are nothing but the numbers. So first we'll understand. So this is the number 201 to 260, 261. So these are nothing but the packets. Okay, so each packet, so number of packets, suppose you are taking the 10 packets, so that is nothing but the window size of your window size of your send receiver is, or send is 10. Now number of packets are 10. Okay, suppose we can see here outstanding bytes sent by not acknowledged. Okay, so you can see here outstanding bytes sent by but not acknowledged, means what exactly? When you sending the data from sender to receiver, suppose I am taking the example 0 1 2 3 4 5 6 7 8 9 10, there are 10 window size. Okay, and then we have sent the packet up to 4 packets. Okay, but we have received the acknowledgement only from 0 to 1, but we have not received the acknowledgement of the 2 and 3 from the receiver. So we can see we have received only the acknowledgement of 0 to 2 and not received 0 and 1, we have not received 2 to 3. So we are shifting our window toward the left side. So our next window will be 2 3 4 5, because we have removed the 0 and 1, because we have already received the acknowledgement of 0 and 1. So 2 3 4 5 our next shifting window. So likewise we are going to work here. So we can see here our window size is almost 201 to 300. So this is nothing but our window size. So we can say 100 is the window size. Now so these are nothing but what? So here below 200, so all these packets are sent, or their acknowledgements is received from the receiver, right? So these acknowledgement are received from the receiver. Now in 201 to 260, sorry, 201 to 260, that is 201 to 260, that is nothing but data is sent but acknowledgement is not received. What I am saying, keep in mind that the data is or packets are sent but acknowledgement is not received. And now next, further is what, 261 to 300, they are not under communication yet, so they are not sent or there is not any operation is performed. So byte that can be sent, and here is the byte that cannot be sent until the right edge moves to the left. So what happen, now when 200 data is sent, then your window will shift here. So again 201 acknowledgement is received, your move to the 301. Again, if the acknowledgement received for 202, then your window will shift towards the right side. So what happened, so as soon as your acknowledgement are received from this side, so your window shift your window will shift toward the next. So I hope you understand exactly what the exactly receiving and sorry, how exactly this window will slide. Okay, so next, so here is nothing but the opening, closing and shrinking the data window. So we can see here, this is nothing but the left wall. So this is a left wall and this is right wall, and this is nothing but the close, close, and we can say, and this is nothing but the open end. So this is nothing but the close end, means it is shifting this words. So in the next, suppose now here in this diagram, acknowledgement of the 200 is received from the receiver but not 20 and 1. So as soon as the acknowledgement of 201 packet is received, okay, 201 is the number of that packet, there is nothing but one sequence number we can assign. Okay, so there is not any value, 201 is not a value, that is nothing but the number of that packet. Okay, that is nothing but the number of that packet. If the 201 packets acknowledgement is received, then we will shift our window size toward the 202 to 301. So it keep moving towards the left side. So this is nothing but the close end and this is open end. So open end means we can take the next byte in windows. Okay, so not from this side. Okay, so this is what the send window of the TCP. So now this is nothing but the receiving window in a TCP. Okay, so now in the receiving side, so there is nothing but what here. So total, this is nothing but the allocated buffer, or we can say, sorry, uh, this is nothing but the allocated buffer or total window size here. Okay, so total window size. Now here we can see the byte received and acknowledgement waiting to be consumed by the process. So here is nothing but what, the byte received and acknowledgement waiting to consumed by process, because what, the I have received the packet from the sender but I have not sent it the acknowledgement. So here we can see the byte that have already pulled by the process, means what, that packet has received and I already sent the acknowledgement. Okay, and here byte that can be received from a sender. Okay, bytes that can be received from the senders, and here is byte that cannot be received from sender. Okay, so this is nothing but what, the byte that can be received from the sender as well as I have sent the acknowledgement. So this is nothing but the completed process, and this is data is received but not acknowledgement sent, or acknowledgement is under process we can say. So this is what left wall, right wall, and it kept moving this side. Okay, so this is nothing but the receiving window. So how exactly the flow control will be run? So if you go into the flow control, sorry, as discussed in chapter 13, means if you go to the book Bohrans and Forzan, that is nothing but one of the TCP/IP protocol book or protocol suite, that is one of the nice book. So if you go into the chapter 30, the flow control balance the rate a producer creates the data with the rate of consumer can use the data. Just a minute. Okay, that can use the data. Now TCP separate flow control from error control. In this section we discuss flow control. Ignoring the error control, we temporarily assume that the logical channel between the sending and receiving TCP is error free. Okay, so in figure, so means that you can observe, you can study that figure in that book. shows the unidirectional data transfer between a sender and receiver. So bidirectional data transfer can be produced from the unidirectional one. Okay, so this is how that things have discussed in that book. So whenever the lecture will finish, I will show you how exactly that figures and that discussion. So we'll have the next topics: opening and closing windows, shrinking of windows, and silly window syndromes. So here we can see the sender and the receiver. Okay, so in the sender and receiver application layer, from the application layer there is a application layer of the sender, and here is nothing but application layer of the receiver. So we are sending the data or message can be pushed from application layer to transport layer. Okay, from the transport layer it goes to the receiver's transport layer. So through the different layers below that, so this is nothing but the segments are pushed. Okay, so segments are nothing but the packets. Okay, so we can, another word we can use the segment. From the transport layer to the transport layer of the receiver we can transmit the segments. Okay, and then this transport layer again push this message toward the receiver's application layer, so that message can be display or that can be utilized at the receiver side. So now there is a flow control feedback. Flow control feedback means your data is successfully received or not. Okay, your data is successfully received or not, because even the TCP protocol itself says that is a connection oriented. So first what, establish the connection, and the data is received. Every time you can receive the acknowledgement, then and then only there is a confirmation of the data received. So there is a flow control feedback which is given to the transport layer of the sender. So then sender gives that feedback to the application layer of the sender. Yes, the data is receiving. So at the user side application layer, user can understand the data is received or not. So here we will take one example. The figure shows the reason for the mandate in window shrinking. Part of the figure shows value of the last acknowledgement and RWND. RWND means receiver side window, and the part B shows the situation in which the sender has sent the bytes 206 to 240. Keep in mind what I am doing here, what I am taking the example. So that will show you that diagram in the next slide. So byte 206 to 209 are acknowledged and per. The new advertisement, however, define the new value of receiving window is 4 as 4, in which 210 plus 4 is less than 206 plus 12. When the send window shrinks, it creates a problem. The byte 240 which has been already sent is outside the window. The solution discussed before force the receivers to maintain the right hand wall of the window to be shown in the part as, because the receiver does not know which of the bytes 210 to 217 has already been sent. So one way to prevent this situation is to let the receiver postpone the feedback until enough buffer location are available in its window. In other words, the receiver should wait until the more bytes are consumed by its process. So how exactly? This is one example that I have taken here. So we will understand exactly what is this. So what, in this situation, what the sender has sent the byte 206 to 214. So byte what, the sender what, he is sending the bytes 206 to 240. The bytes 206 to 209 are acknowledged. Okay, so what, 206 to 209 means how many, the four bytes are acknowledged, means they have received the acknowledgement. Now in the new advertisement, they define the new value of receiving window is 4, in which 210 plus 4 is less than 206 plus 12. That is nothing but the one formula for the shrinking, to prevent the shrinking. So what, so there is nothing but it does not follow, because the 210 plus 4 is greater than 206 plus 12. So it should be a greater than. Okay, so but here is less than. So it is nothing but there is a shrinking of the window. So how it can be prevent? So it is nothing but the problem in the, so how it can be prevent, that I will show you in the next slide. So there is nothing but what, to prevent the shrinking of the send window. So new acknowledgement number plus new receiving window size is greater than or equal to last acknowledgement number plus last receiving window size. So this is how the formula for prevent the shrinking of the window. So exactly what shrinking? Now the windows is open, closed or shrunk. There are three activities. Okay, open, closed and shrunk. So these three activities we will see are in the control of the receivers and depend on the congestion in the network, not the senders. The sender must obey the commands of the receiver in the matter. So opening a window means moving the right wall to the right. Okay, what I am saying, I hope you are understanding. Opening window means what? Moving the right wall to the right. This allows more new bytes in the buffer that are eligible for sending. Okay, so if you are moving the right means you are sending the new bytes, or those are eligible. Now closing window, the closing window means, okay, so just a minute, I will take this example later, but I will explain what is the closing, shrinking and opening. Now the closing window means moving the left wall to the right. Okay, moving the left wall to the right. So in the previous slide we have seen that. Okay, so in this slide we can see this. So this is nothing but the closing window means moving the left wall to the right. So this is nothing but left wall is moving towards the right. That is nothing but what? The closing window. And opening window means moving the right wall to the right. This right wall is moving towards the right. That is nothing but the opening the window. Now shrinking the window means moving the right wall to the left, moving this right wall to the left. Okay, moving this right wall to the left, and this is strongly discouraged and not allowed in the some implementation, because it means revoking the eligibility of some bytes for the sending. So this is not allowed. So moving the right wall to the left, that is not allowed. So this is nothing but what? Shrinking our window. Okay, so this is not allowed. So this is problem if the sender has already sent 3 bytes, and note that the left wall cannot move to the left because this would revoke some of the previously sent acknowledgement. Okay, so this left window cannot move to the left. Okay, this is not, if you move this right toward the right, so this is not move to the left. Because why? Because already this senders already has acknowledged that bytes, because this bytes already sent, and sender also receive the acknowledgement, because left wall should move towards the right, and right wall also move toward the right. So this problem should not occur. So when these problems occur exactly, that will come to that slide. Okay, so how exactly? So this is what the formula. So this is what the formula. So new acknowledgement number plus new receiving window size is greater than or equal to last acknowledgement number plus last receiving window. So now you can see here the last advertisement acknowledgement number is 206 here. Okay, so here is 206. Just a minute. So here is last acknowledgement number is 206, and last advertisement window size is 12. So what is this? 206 plus 12. So how much it is? 218. Okay, it is nothing but 218. Now there is a new advertisement acknowledgement number is 210. Okay, 210 plus new window size, that new window size is 4. This is nothing but what? 206 is, this is last acknowledgement number, so this one, and 12 is new window size, sorry, last window size, that is nothing but 12 is equal to or greater than new acknowledgement number. So new acknowledgement number is 210, that is 210 plus new window size, that is 4. Okay, so that is nothing but the 4 that have given the example last, that we have taken the example. So this is what? So this is 210 plus 4 is equal to 240 is equal to 200 and how much? 218, right? So greater than equal to, so this condition false. Means what? This is nothing but preventing the, or sorry, this is nothing but the shrinking of the window. So this condition get false. So this should be what? So this should be 240 is greater than or equal to 280, or is greater than or equal to. So that is why there is nothing but the shrinking of the window. So if you want to prevent this, okay, if you want to not go your window in a shrinking mode, so what we have to do, we have to take, or we have to follow this thing. So your new window size is greater, or there should be a new acknowledgement number is also a larger. Okay, so I hope you understand exactly what is that. So now we are going to in a next topic, that is silly window syndrome. So sending data in very a small segment, that is nothing but the, okay, so in the first scenario, the syndrome created by the sender. So sending application program creates a data slowly, that is example 1 byte at a time. So wait and collect the data to send in a larger block. And how long should the sending TCP wait? So it has the solution is Nagl's algorithm. Okay, so that is also one of the algorithm that can be used. Okay, so in the, what exactly Nagl's algorithm says, the sending TCP send the first piece of the data, and it receives from the sending application program even if it is only 1 byte. So after sending the first segment, the sending the TCP accumulate data in the output buffer and wait until either the receiving TCP sends the in acknowledgement, or until enough data has accumulated to fill the maximum size segment. At this time, the TCP can send a segment. Okay, so each step 2 can be repeated for the rest of the transmissions. Okay, so this is how the silly window syndrome means the speed of the application program that creates data and the speed of the network that transport the data. So here in the receiver side, the receiver application program consumes the data slowly. The receiver TCP announces the window size 1 of the byte, and sending the TCP sends only 1 byte. Okay, so that is nothing but the Clark solution. Okay, so this is what window size. Okay, so that is nothing but third is the delayed acknowledgement. Okay, this is not very important. So we are going for the next, that is error control. So this is how very important now, the error control. So TCP is a reliable transport layer protocol. So reliable transport layer protocol means, so that is nothing but the data sure send. So so we have to receive the acknowledgement. Okay, if you receive the acknowledgement, then and one only that TCP protocol should follow. So that deliver the stream of the data to TCP relies on the TCP to deliver the entire stream to the application program on the other end in order without error and without any part lost or duplicated. Okay, so error control in TCP is achieved through the use of the three tools: checksum, acknowledgement, and timeout. If you want to receive your data successfully, so you have must receive the acknowledgement as well as your data should not lost in the transmission, and you should receive the, or you should not receive the duplicates. Means what? The same packet 1 can receive the twice at the server side. So this is nothing but duplication of the packet. So that should not be done. So we are going to discuss in this topic checksum, acknowledgement, retransmission, out of order segment, FSM data transfer in TCP. We are not going to discuss the FSM and some scenarios. So first, acknowledgement type. In the past, TCP used only one type of acknowledgement, accumulative acknowledgement, also namely accumulative positive acknowledgement. Okay, so positive acknowledgement means what? So we have received, yes, I have received the data. Another more and more implementation are adding another type of acknowledgement, selective acknowledgement, or that is called as a SAC, is implemented as an option at the end of the TCP header. It is used for the end of the TCP header. Okay, so now rules for generating the acknowledgement. When one end send a data segment to the other end, it must include an acknowledgement. So this gives the next sequence number it expects to receive. Okay, so when you sending the data to the receiver, so it receives the acknowledgement, so it includes the one sequence number. Now next, the receiver needs to delay the sending until another segment arrive or 500 millisecond. So an acknowledgement segment, if there is only one outstanding in order segment, it prevents acknowledgement segment from creating the extra traffic. Okay, so there should not create the extra traffic, and there should not be more than 2 in order unacknowledged segment at any time. So it prevents the unnecessary transmission. Means what? So there should, suppose you send the 2 frames and still we have not received the acknowledgement of the both, and still we are sending the next data. Okay, so this is not allowed. If the one acknowledgement is not received from the last sender, last sending frame segments, then you have to send that packet as soon as. So there you should not wait for the 2 unacknowledgement packets, okay, or segments. Now next, when a segment arrives with out of order sequence number that is higher than expected, the receiver immediately send an acknowledgement segment announcing the sequence number of the next expected segment. That is nothing but the fast retransmission. Okay, so you understand all these rules in the coming slides. When a missing segment arrives, the receiver sends an acknowledgement segment to announce the next sequence number expected. And if a duplicate segment arrives, the receiver immediately send an acknowledgement. So this is what rules for generating the acknowledgement. Now we are going to discuss now how exactly these rules can be followed. So first we'll go for the normal operation. So what exactly normal operation can be happen? So first here, so client and server. Okay, so client and server. So first client send the client send the data, okay, towards the receiver server, or we can say receiver, and the receiver send the acknowledgement. Okay, acknowledgement. If in a after, okay, so first there is a first there is establishment of the connection. After establishing the connection, so we can see after a 500 milliseconds you can send the next data. Okay, so if again you can receive the acknowledgement of the same, right? And again if you send the next acknowledgement, sorry, if you send the next data. Okay, this is how that is the normal operation can be happen between a below 500 milliseconds. So sending the data, receiving the acknowledgement. So this is very normal operation should happen. Now what happen when there is a lost in the segments? Okay, what exactly there will be the lost in the segments? So we will discuss here. So you are sending the data from the client to receiver. Again you are sending the data and you are receiving the acknowledgement. Okay, you are receiving the acknowledgement. Again you are sending the data. Okay, but what happened? You are sending the data and the data is lost in between the network, in between the transport layer. Okay, in the transportation. So what happened? There will be a rule 4. Now what is the rule 4? When segment arrives with the when segment arrives at the out of order sequence number that is higher than expected, the receiver immediately send an acknowledgement segment announcing the segment number of the next expected segments. Okay, so what the rules 4 says, suppose there is a next packet is received, okay, but there should not receive the acknowledgement. So what it can does, so it can, just a minute, so it can again send the next packet. Suppose there is a acknowledgement 701 is received here, and he send the 701 and 800, that is that data is lost in between that. So what it can does, again it send the next packet immediately. Okay, same packet it can send immediately because he has not received the acknowledgement of the that. Okay, so he has resend that packet. You can see 701 800 it can send the packet because he has not received the acknowledgement. So here there is a lost in the packet, so he can send the next data and he has received the acknowledgement of the this 801 900. He has not received the acknowledgement of this one, so he has again resend the packet and when he receive the acknowledgement. Okay, so this is what the lost segment. So fast retransmission. So in the fast retransmission, what happened? Client and receiver is sending the data, okay, receiving the acknowledgement. When there is a lost in the packet, but still it continue the sending a next packets, okay, and receiving the acknowledgement. But after some time he realized that he has not received the acknowledgement of this 301 sequence number 301 and acknowledgement X. So again in between, after stopping the current sequence transmission of the packet, he has again sent the previous packet, okay, and then receive the acknowledgement. Okay, so that is called as the fast retransmission. So suppose there is a frame number 1 2 3 4, he is sending, and in between what happened, two numbers packet is not, acknowledgement is not received. So after 3 and 4 again he send the acknowledgement number, sorry, packet 2. Okay, now the loss of acknowledgement. Now what happens, sometimes not only the data is lost, sometimes acknowledgement is also lost from the receiver to sender. So at that time what happened, so you can see here, so he is sending the data and here is lost of the acknowledgement. So 601 and 700 packets he has received as receiver, but while sending the acknowledgement, acknowledgement is get lost into the in between the network transportation. So what happened, then again there is a there is again sending the same packet. Okay, there is a sending the same packet and then he receive the acknowledgement, still he is not receiving the acknowledgement, the client or sender can send the data. Okay, and the lost acknowledgement corrected by resending a segment. Okay, that I already explained you. There is a continuation, in the continuation there is not received the acknowledgement of this data, acknowledgement 701. So if there is a 501 sequence number that he has not received the acknowledgement, so he can resend the data. Okay, he has received at the receiver, but there is a acknowledgement is get lost in between, so the client has to send the data again. So this is what about the uh, today's flow control and error control. I hope you understand. If you have any queries and doubt, you can message me or call me back. Okay, so thank you very much for today's lecture.